Welcome to eDNA Tech. In this video, we are going to see how the LCD display works and how we can program our LCD display. So we move on to the datasheet of our LCD display. So it has some features in the first day. 5x8 dots with cursor. It has a 5x8 LED dot matrix and 16 characters in 2 lines. So you can display a 16 characters, and it has 2 lines of 16 characters. That means 32 characters can be displayed at one shot. So next, 4-bit or 8-bit, you can configure with your LCD display with 4-bit or 8-bit. So what is the difference is, for 4-bit you want to send the values 2 times because all the values are 8-bit. So the communication is between 8-bit. So if you want to use a 4-bit, you want to send 2 times, and the execution speed is also increasing compared to 8-bit. So better use 8-bit. There is a built-in controllers. So this is the layout of our LCD display. If you want to mount it on any of the PCB, you can see these measurements, so you can make a PCB of your own. So this is the block diagram of a LCD display. So it contains LCD panel which is above. So this is LCD driver and a LED backlight. So if you want to check whether your LCD display has a backlight or not, you can just give a positive supply and negative supply. That means plus 5 volt to this anode and cathode, and you can see the LED backlight will glow. So next, there is data pins which can be configured. So it will make your characters to display with the help of controller and driver. So you want to program this to display your characters. So it has 3 power supply pins, VDD, VSS and V0. Why they mention V0 is for the adjust the contrast of your character display. So the difference between LED backlight and the character display backlight is nothing. So it will only adjust the contrast of character display. Let me show you how it is seen. Here you can see it has a high contrast. When we rotate with the potentiometer, the contrast is slowly making dim by dim. So if you want to adjust the contrast, use potentiometer to adjust the contrast of this character display. So the next thing we are going to see is the register select and read write. Register select is nothing but if you are configuring the LCD display, you want to make the register select as 0. If you are writing the value to the LCD display, you want to make the register select high. Next, there is a read write pin which you can use to write or read. So if you are going to write, make a 0 to this, and if you are going to read, make it just 1. So we are already grounded because we are only going to write the values. So enable, it should be high whenever the data is written. So this is the data pins for 4-bit. If you are configured as a 4-bit, these 4s are not used, only DB4 to DB7 are used. If you are configured for 8-bit, both these are used. Next, here you can see a write mode diagram. The RS pin is either high or low depending upon you are going to configure or write the data. The write pin is always low because we are writing more. So the enable should be high whenever the valid data is sent. So we can see here the function description. So you can configure as 4-bit or 8-bit bus with the help of DL bit. So they are given below the instruction table. If we go through this, we can have an idea. So there is an address counter, so which stores the address of DDRAM or CGRAM. AC is automatically increased or decreased by 1. So if you are going to write your values in a continuously, then it will automatically increase the next one like that. So next is a display data RAM. So this is the main thing that is going to display our character. So there is a address for each character display. So it has a 16 2 lines, 16 plus 2 lines. So for each character it has a address 0001. So if you want to write a value in a 7th position, then the DDRAM address of 0x06 should be written with a value which should be written. For example, you want to display character here like A, so you want to write the address of 0x06 and the value of A here. So you can display the A at 7th position. So the DDRAM address will change for different manufacturers. So you should see which manufacturer you have used. So for example, if you are using LM0444L, then the DDRAM address will be 80 and C0. So the starting of the first line and second line address may change. So before using it, see the configuration. Datasheet of the LCD display, you can understand what is the DDRAM address. So the CG-ROM character generator ROM has an inbuilt characters of about 204 character patterns, which is the ASCII table. In the ASCII table, what are the characters available? All the characters have been generated there. 5x8 pattern values. So what will be the values inside the CG-ROM is nothing but, let me example of A. Take an example of character A. If it is a 5 columns and 8 rows, the A character will have a value of 0x00 like that for 5 columns. These 5 columns values are stored in a CG-ROM. If it is a row major, it will have like this. So depending upon the values, the manufacturers, the CG-ROM has different characters values. So they are already inbuilt of 204 characters. If you want to generate your own characters, then use a CG-RAM. So you can generate your own character patterns with the help of CG-RAM data. So the next video we are going to see how to generate our own characters. In this video we are discussing only about displaying a character. So this is the instruction table. You can see there are different instructions we can perform with the help of sending a different values. So here they have given options like many things. So you first on the display, next you can use cursor or you can off the cursor, you can blink or off the blink of the cursor, so you can move like that. There are many functions. So for this explaining, we move on to the program. So I have already written a program to explain the characters display like the things. So for first we need to connect the data pins. I have connected all the data pins to the port D of Arduino UNO, and the port C is connected with the enable and RS, register select and enable. So I have initialized our port D direction register address is 0x2a, and I have given a value of 1 to that all the direction register value. So that means I am making it as output. If you are going to give a value of 0 to the port D direction register, then it will go configuring as input. So I have initialized port D and port C as output, and I am going to write a values to the port registers with the help of this function. So the data direction of data register of port D is 0x2b as the address, and you should write whatever the value you are going to write is passed here, and the data one is passed to this address. So it is for port C. So next, the enable pulse. So I am generating a enable. So the enable is connected for first bit, so I am making it as 0x01 and making a delay and making 0 on and off like that thing. So literally it's on, is off. So enable pin, first pin is connected to the first pin, so on and off. And these are the some functions, so just omit it. So first we are going to initialize our LCD. So before initializing, first we are going to set our function mode. Function mode has 3 parameters. One is DL. So let us see in the instruction table. So where is the function set? Here you can see it has DL and N and F. So DL is nothing but data length, either a 8-bit or 4-bit. We are using here 8-bit, so we are going to test 1. So the next, the number of display line, either a 2 line or 1 line. So we are going to write it as 2 line, so that means 1. If you are using 1 line, make it as 0. Next, display font type, either 5x11 or 5x8. We are using 5x8, so we are going to make it as 0. So what is the equivalent hexadecimal value of this 8-bit? So 0011 is nothing but 3, and 100 is 8. So that's why the value will be 0x38. So if your next thing, if you are going to write, so I have written a binary of that 8-bit here. So next thing, display set or not. So here you can see display on or off control, and you can set our display. That means we are going to on our display, means we are making this value as 1. And if you want a cursor, make it as 1. If you don't want cursor, make it as 0. If you want to blink the cursor, make it as 1. If you don't want to make it blink, make it as 0. So I have first we can understand by making it as C. So first we are going to only on the display, no cursor, no blinking. So next move on to the let me erase this all this thing. So first we are going to write LCD. So what we need to do to write a character to the LCD display? In the right diagram we have seen, whenever the valid data is there, the register select should be high, and the read write should be low, and the enable should be high, and the valid data should be sent. So I am making a data to the port D register, and I am going to on the RS. So I am making it as RS high, and next we are going to make enable also high. Next, off the enable. Whenever the data is sent, please shut down the enable pin. So this is the function to write a data to the character display. So you are going to write a data to the character display with this function. So clear display is nothing but they have given a separate function. You can clear the display before, so making a 0x01 to the output D register, you can make the display clear. So that means whatever the data written on the display will be erased by calling this function. So we are going to send a value of binary 1 to this data pin and enabling this. So make a clear note, whenever the commands are sent, the RS should be low. Whenever the values are sent, the RS should be high. So that's why I have not used RS value here anywhere. So the next thing is we are going to write a value to our LCD display. So just call a so there is a error because the function name differs what I have written here. So now it should work. So here you can see the A is displayed here. There is no cursor, or the cursor is not blinking. So let me check. The next thing, we should on the cursor. So for on cursor, you should make a value high. So I already make a comments here. So here you can see, if you want to on the cursor, make it as 1. So all the ones is E, the equivalent hexadecimal. So you can see the cursor here. Before there is no cursor, now there is a cursor here. Next we need to blink this cursor, so you can make F here, making all the bits as high, so the cursor will blink. Here you can see the cursor is blinking. So how much commands we have done? So this command is completely understand, and this is also not understand. Wait. So function set mode we have finished, and display on and off finished, and the clear display we have also known. So the return home is nothing but the DDRAM address will be to the first position wherever it is increased or decreased. So next thing we want to know about is if you want to set the DDRAM address. So like if you want to write in the 4th position, so we want to set the DDRAM address. So for that I have made a separate function for writing DDRAM address. So I'm calling this function (0x84) means I am going to write it at the 4th position. So if you want to write a value at the 4th position, you want to set the DDRAM address to 0x84. Because I am using LM04L Hitachi, so you are going to write at the 5th position means 0x84. If 3rd position means 0x83. So if you are using other than that, you should write simply for this manufacturer. So before writing a values, check with the datasheet on the manufacturer's datasheet. So if you are going to write a value 0x84, so you can see the A is written at 5th position. So the DDRAM address is set to the 5th position, and the value A is displayed at the 5th position. So we have completed how to write a value at a fifth position. So the next command we should know is that, so we have completed say DDRAM address. The next one, cursor or display shift. So let me explain it in detail. First, before that, we are going to make a how to display a string. So this is a function to display a string. You can display a string using this function. So I'm going to literally write a hello like that thing to understand. So typically we have made a initial address of 0x84 to start at fifth position. The H is started as a fifth position and the hello is continued type. So next we are going to know how to shift our cursor before or after. So there is a function called cursor or display shift. You can shift your cursor from left or right. So here you can see there are the four possible ways by writing the values to S or C or R or L. So if you are going to write the values of four different types, you can either achieve these four different types of operations. So let me check one by one. So first we are going to shift the cursor to the left by writing 0 0 to this. So I have already made a cursor or display shift function. So I am making this RS as low. So whatever the data is written here, it will be sent to the display. So we are going to cursor or display shift. So I am going to copy this function. So to see the difference, we are going to make a delay here so we can see what happens. First the value should be 1 0 0. So that means 0x01 1 and the remaining 4 bits are all are 0. So literally 1 0. So first we are going to give it as 1 0. Let us see what happens. Here you can see the cursor is shifted left. So the shift the cursor to the left and AC is decreased by 1 if you give 0 0. Next we are going to give a value of 0x01 and see what happens. So if you are going to send a 0x01, so the equivalent hexadecimal is 14. So if you are going to write a value of 14 here, the second operation will be seen. Here you can see the cursor is shifted right. So the second operation is also performed. The third operation is 1 0. So if you are going to give a 1 0 means the equivalent hexadecimal will be 1 8. So what happens if you give 1 8 here? Here you can see the display is shifted left by 1 bit. So next the cursor are also moved to the left depending upon the display shift. We have written a value H here at the 5th position, but the hello is in the 4th position. So the display is shifted by 1 left. So next we are going to display the shift by 1 right, means we are going to read 1 1 here the equivalent hexadecimal will be 1C. Here you can see the difference. The display is shifted by 1 and the cursor is also shifted by 1. So the 4 operations is also understood by the things. So depending upon the values, we can shift right or left the display or cursor by using cursor or display shift. So the remaining commands which we want to discuss is about the entry mode set. So only thing which is remaining is entry mode set. We are not going to discuss about read data RAM or read BC flag. So the remaining is only entry mode set. So what is the entry mode set? So if you are going to write, let me explain with this. So I have already made a function for entry mode also. So what are the values can be changed? So for the entry mode, the value should be increment or decrement or shift left or right. So what is the increment or decrement? The cursor blink or moves to a right, the cursor blink moves to the left. If ID is low, ID is right. So let me see with the example. So what the value should be given? So literally 0x04 for nothing, here you can see if we give the values of 0 and 0 here, that means no shift of display and no, that means a decrement. So I is, this bit is 0 means it is decrement, if it is high means increment. So the cursor will be decremented one by one. We are written at 84 and the next DDRAM will be here, but usually the data will be written one by one in the right side. If you want to decrement the values and return, you can use this entry mode set, either from right or left. It will be allocated by using the entry mode. So now we are going to make it as increment, so you can see the difference. So if you want to write a 1, that means 6, the hexadecimal equivalent will be 6. So you can see hello. So the hello is written from left to right, so it will be increment one after one. The DDRAM will be incremented at the right. So the next function we should check is shift of display. So by each time the display will be shift from one by one depending upon the increment value. So if the increment value is high, the shift will be at the right side, and if it low, it will be on the left side. So let me see how it works. So we are going to make it as a 7 here. So let me to show you a difference, I am going to use a write LCD command. So we are going to write a hello separate. So just copy paste this thing. Now see the difference, how the hello is printed. So write LCD, the function name is wrong. That's why please copy paste. Then run the program. Here you can see the H is printed. The next, the display is shifted by 1 and then E is printed, and the display is shifted and the L is printed, and the display is shifted right and the L is printed, and the display is shifted right and the O is printed. So the for each time writing the LCD data, the display is shifted by 1. So it is shifted by right. If you want to shift it by left, you can use this. So you want to give a value of 0 to the here, that means we are going to decrement and making as a shift display 1, and means the equivalent will be 5. So let us see how the hello will display now. It will shift by left this time. H is printed. The next time shift H here and E is printed. The next shift H here and E is printed, like that go. So if you to know how is printed, so let me change the position so we can clearly visible what how and HE is printed. You can see shift one time and the next character is printed, shift one time, the next character is printed, shift one time and the character is printed. So for each time character shift, the display will be shifted one time. So that is the function of entry mode. So you can use this entry mode for rotating display like that thing. So these are the LCD commands that should be known. You can make different types of programs with these commands, so you can clearly understand how the commands works. So in the next video we are going to see how we can generate our own character and how we can rotate our display like that thing. So see you in the next video, and